morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And today we are talking about the tangent function as the bumper music. Escorting us in is Crazy Train from the legendary Ozzy Osbourne. Straight off the Hot CD Days phase produced by the great Darby Foster. Let's get to it, shall we? All right, love me some Crazy Train. So, tangent function, as we know from previous discussions in class and whatnot, tangent x is equal to sine x over cosine x. And we're talking about the graph of y equals tangent x today. So that is of particular importance when graphing because tan x will be defined whenever cosine is equal to 0. And of course, that's because we cannot divide by 0. Where is cosine equal to 0? Well, the most obvious place, I think, is at pi over 2. The cosine of pi over 2 is 0. Therefore, in the graph of y equals tangent x, we have a vertical asymptote at pi over 2. And if you recall, cosine of 3 pi over 2 is also 0. And if you think about it just a little bit, it's going to be, cosine's going to be 0 every pi units, every multiple of pi, as shown here. So there are vertical asymptotes for the graph of y equals tangent x for x equal to pi over 2 right here, and then every multiple of pi to the right and to the left. Hence, k is equal to, or is an element of the set of integers. There is a period of pi. See how the function repeats itself, left to right, every pi units. And the range, since the tangent function goes to positive infinity and to a negative infinity, is the set of real numbers. And I put this chart here so you could see where tangent comes from. Just real quick, let's go through the first quadrant. Tangent of 0 is equal to sine over cosine. 0 divided by 1 is 0. So that's that point right here. Tangent of pi over 6 is 1/2 over root 3 over 2. Simplifies to root 3 over 3, and that point is right here. So that's at pi over 6. And then where are we going? 45 degrees, pi over 4, same thing, that's easy. So that is equal to 1. They don't have that point there. That should be right here. And then pi over 3, it's equal to square root of 3. It's up here. And notice, as you get closer and closer and closer to pi over 2, if you think about your unit circle, sine is getting greater and greater and greater, and cosine is getting lesser and lesser and lesser, therefore producing a graph that is going to take off to infinity. The same idea happens as we go from, say, pi to pi over 2. I know I was over here, but it's the same idea. From pi to pi over 2, it's just that cosine becomes negative, and therefore we go down to negative infinity. A nice, beautiful pattern for tangent with the asymptotes in mind. Okay, so the principal axis is y equals d, just like with sine and cosine. And that's because if you look here, if you look at the x-axis, which is the principal axis, y equals 0, it does cut the tangent graph exactly in half. It's where it equals 0. And while it's the same shape, it's a couple of transformations, maybe a reflection over a vertical line and then a reflection over the line y equals x. Not the line y equals x over the x-axis to get to it. So you can see that it is still, there is still some symmetry there. The period is pi over b. Since the tangent period or repeats itself every pi units, instead of 2 pi over b, it is pi over b, and we already talked about the amplitude. So let's sketch it, okay? So without using technology, we're going to sketch tan of x plus pi over 4. So that is just tangent x shifted pi over 4 units to the left. So I'm actually going to do 2 graphs. Here's pi, here's 2 pi, and here's 3 pi. And then I'm going to put in my pi over 2's, boom, boom, and boom. I'm also going to put one over here, and I'm going to put one over here as well. So this is pi over 2. This is negative pi over 2. This is 3 pi over 2. This is 5 pi over 2. And this is 7 pi over 2. Now my domain is only from 0 to 3 pi, but just bear with me. I want to put in my asymptotes, okay? Within our domain, we're going to have an asymptote at pi over 2, at 3 pi over 2. Oh, messed that up a little bit. Let's come straight down, Mr. B. Okay, and then at 5 pi over 2. So that's within our domain, okay? But I'm also going to put it, just for our tangent graph, I'm going to put them in at 7 pi over 2 and also at negative pi over 2, just so we can see what the graph looks like. So tangent looks like this. Remember, it's going to go up, 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 and down, 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 down. And of particular importance, at pi over 4, that's where tangent is equal to 1. Okay, so this is at our pi over 4s. And we'll talk about that in a second. So it's just going to be a continuing iteration of these nice smooth curves. Oops, what's the matter with me there? So this is going to go like this, and then like this. Okay. So this is y equals tan x. But we have to get used to that before we can shift it horizontally or vertically. Okay. So now we're going to do the same dealio. So pi, 2 pi, and 3 pi. And put in our pi's over 2's. Okay. And I'll put in 1 here, negative 1. Okay, but we're shifting to the left pi over 4 units. So I'm going to put that, I'm going to put in our pi over 4 units right here, and here, and here, and here, and here, and here. Okay, just so we can reference them, because that's everything. Everything is shifting pi over 4 units. Okay, so first thing we need to do is shift our asymptote. So this asymptote is going to go to pi over 4 here. Then this is going to go to the pi over 4 between pi and 3 pi over 2. Which one is that? 5 pi over. It's 5 pi over 4. So it's going to go here. So I got an asymptote here. Boom. And then another asymptote. It's not here. This is going to be our mid one, right? Because we're shifting from 3 pi over 2, which is here, to pi over 4 units. And then one more is going to go right here. All right, so now let's think about where the asymptote just to the right of this would be. So it's going to be another pi unit. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So just here would be another asymptote. And it is not part of the domain, but I'm just going to put it there temporarily. Okay. And now let's just do the easy ones. So this, you know, this graph right here is this guy moving over to the left. So when I have two nice asymptotes for tangent, I can just do those right away with the shift because I know exactly what they look like. Okay, so let's think about what's going to go here. So on tan x, when x is pi over 4, y is equal to 1. And if we shift that left pi over 4 units, it's going to hit 1 exactly. So we'll put that point there and go up, 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 forever and ever and ever. And then this one, okay, let's see, another pi over 4 units right here, it's also going to be equal to 1. That's not quite as good of a graph. It's going to shift, or as accurate, I should say, it's going to shift pi over 4 units. So at 3 pi, I'm also going to be at 1, right? And that's going to make this look a bit like that. Okay? If you think of this asymptote moving over just a little bit, and we really shouldn't have that asymptote because the domain is just from 0 to 3 pi, so we don't want to get any points off. So that is what it would look like. Okay. Let's take just one more. Okay, again, this is going to be from negative pi to pi. So let me move these guys a little bit. Sorry about that. Boom. Boom. I thought we were going to 3 pi again. Okay, so let's do tangent again. So from pi to negative pi. And let's do our pi over 2s, negative pi over 2, pi over 2. And those are where our asymptotes are. Right here. Okay, so between two asymptotes, tangent is always going to look like this. Boom. Boom. And tangent is a little funky, so I recommend always doing tangent x before you do anything else. And so it's not going to go up like from here, it's going to go down. Just think of the pattern right here, and then here it's going to go up. Okay. Well, what about this 2x here? Well, remember the period is equal to pi over b now, yes? So the period is going to be equal to pi over 2. Boom, okay? So that is going to just squeeze everything in. Remember that the distance from between these two is now pi units. And what I have to do now is make them pi over 2 units. So let's do the same, about the same scale. So here's pi, and here's negative pi. Here's pi over 2, or I'm sorry, negative pi over 2, and pi over 2. Okay, and let's think about this. What is the tangent, if I let x equal 0, what is the tangent of 0 going to be? Well, 2 times 0 is 0, and the tangent of 0 is still going to be 0. The only difference is the period is pi over 2 units. So that means it's going to be, the tangent is going to still increase this way and decrease this way. It's just going to do it every pi over 2 units. So we're just moving our asymptotes in. So this is it's going to go from a pi over 4 to a negative pi over 4. And let's think about that real quick. We'll just think about the pi over 4 here. Okay, if x is 2 pi over 4, 2 times pi over 4 is equal to 2 pi over 4 or pi over 2, and tan of pi over 2 is undefined. So that is why, another reason, or another way to think of, I should say, we're going to have vertical asymptotes every pi over 2 units. So let's just go ahead and get those in there. Yeah, very nice. And so then the next one would be some from here to here is pi over 4 and halfway between. This is 2 pi. This is 3 pi over 4, right? So very nice, very easy right here. And this is pi over 4 units, so we don't have an asymptote here. And then another pi over 4 plus another pi over 4, one more asymptote. Bam. Okay. And then we'll sketch the easy parts, the one that have 2 asymptotes. It's just going to go a lot steeper than our other graph. Okay, so we're going to go up here, down here, up here, down here. So we're going up this way. That means this part's going to be going down. Ooh, that was awful. Let me redo that one. That's embarrassing. Got to get closer to the asymptote. Boom. And then from negative pi, it's going to go up like that. Okay. So once you get used to this curve and then the compressions, the different periods, the shifts, tangent is actually a fairly simple, a pretty simple graph or function to graph. All right, that is it for tangent. I know you enjoyed it. It was awesome, particularly with the crazy train going in the background. Let's go back with the legendary Ozzy. And with that, I am out!